In previous video, we have revised what we have covered last week, as well as we have just started what is propeller shaft and how it works. Okay, now in this video we are going to see what are the different types of propeller shaft, and as well as we are going to discuss universal joint. Okay, and just see, we have seen the propeller shaft history. We have seen previously we are using chain drive for transmitting the power from drive to the wheel, but they are having various disadvantage, and the new vehicles requires a reliable and very good drive, and for that purpose the propeller shaft are invented by these Lanchester brothers of Britain, and these are modified by Renault of France. And we have seen the main function, as its name indicate, propeller shaft means, as its name indicate, propels the vehicle. It is also called as a drive shaft. Okay, the main two function of the propeller shaft is to transmit power from gearbox to rear axle without changing speed. Why? Because due to the movement of up and down of differential, there is chances the driving speed and driven speed are different, and to match it in propeller shaft, the angular distance or angles are taken care by the universal joints, and the line and length, here the difference in line and level of gearbox of output shaft is different, and these are covered by using the slip joint. We have already discussed this in previous video. Now we will see the two types of propeller shaft. First is torque tube propeller shaft, and second is Hotchkiss type propeller shaft. Now we will discuss torque tube propeller shaft. A torque tube is a larger diameter tube fastened securely to the rear axle housing and completely enclosing the propeller shaft. Okay, the torque tube is fitted in the spherical coupling and the socket surrounding one universal joint at the transmission end. Okay, these two units, first is the spherical ball and second the socket surrounding one universal joint. These both units carry the respective loads while allowing suspension flexibility. The normal engine power transmission takes place through this propeller shaft. Okay, but the braking and acceleration causing sudden torque are taken or borne by these torque tube. Okay, this is very simple construction. And the second type of propeller shaft is Hotchkiss type propeller shaft, and in this type of the propeller shaft, the driving and braking torques are absorbed through the half of the rear axle spring or through the link and arms when used with coil springs. Okay, in previous case we are using torque tube to bears the load of driving and braking torques absorbed through leaf spring. Okay, here the leaf springs are arranged, as well as the link and arms are used coil springs. Thus the normal power is transmitted through propeller shaft, and the acceleration and braking shocks are taken by this leaf spring. Here are the leaf spring clamp in the middle, and by special link frame in case of leaf spring. Okay, here are they shown the construction of Hotchkiss type propeller shaft. In exam point of view, in examination, they may ask what is propeller shaft, what is the function of propeller shaft, and write any one type of propeller shaft. Okay, at that time you should able to draw these figures and you should able to write clearly. Okay, now means what we have covered. We have seen the torque tube propeller shaft. In this torque tube propeller shaft, the two units are there. First is a spherical ball and second is socket surrounding one universal joint at transmission end, that is the torque tube. Torque tube bolted at the axle, and this is the rear axle. The main sudden load or braking torques are taken by this torque tube, and in Hotchkiss type this will be taken by the leaf spring and the link arms. Okay, now we will see the universal joint. Okay, here we know what is universal joint. In second year engineering you have studied the universal joint, or the coupling which is used to transmit a power from one shaft to another shaft when they are not linear, when there is angular power transmission. There at that time you have to use universal joint. You have learned this in machine drawing as well as theory of machine and design part. Okay, so let us see the once again we will revise how is universal joint. First, when the shaft axes are not collinear but they are intersecting, at that point the universal joint is used and it takes care of angles. In this diagram you will observe that this is the gearbox shaft axis, driver shaft, and here we have to transmit the power at differential end, differential shaft. This is the axis. These are parallel to each other. Okay, and here the power is transmitting from gearbox to differential shaft with the help of propeller shaft. Okay, here the propeller shaft is inclined, and in that case the speed or the power at gearbox shaft axis must be same at the power or speed of the differential shaft. That both must be same, but it not happen because of these irregularities on the road, and the differential is always moving, always making ups and downs. That's why what you have to do, you have the main function of the propeller shaft is to transmit the power without changing the speed. At constant speed you have to transmit the power. Okay, so in this case the angular, these angles are taken care by this universal joint. Okay, the construction features here we have seen. This is the yoke and this is the spider or the element which is common to both the yokes. Okay, this is the one universal joint. We are using one universal joint at gearbox and propeller shaft, and one universal unit at propeller shaft to differential pinion axis. Okay, and we are using two universal joints. Okay, and just we will see the construction requirement. Already I have discussed. In this case the angle between the gearbox output shaft and propeller shaft, and that between propeller shaft and differential input shaft, means this angle and this angle should be equal to each other, and that care will be taken by these universal joint. I think you understand it better. the speed variation between the gearbox shaft and the propeller shaft is corrected by this universal joint, and the same speed of the differential input and propeller shaft is again corrected by this second universal joint. Means that's why you have to use two universal joints. Okay, here there are different types of universal joints. First is hook universal joint, and second is double cordon universal joint. Third is Bendix Wicks universal joint, and fourth is ball and trunnion joint. Okay, see, the universal joints are also known as Carson joint or Hooks joint. Previously, the universal joint was invented by Girolamo Cardano in the 16th century, but he has failed to maintain the constant velocity during the rotation, and it is recognized or observed by the Robert Hooke, and in 17th century Robert Hooke has proposed the first constant velocity joint, okay, consisting of two cardinal joints offset by 19 degrees so that they can cancel out the velocity variations. Just see how it looks like. Okay, here the animation is shown of simple universal joint from driver to driven. When they are angular, in there is variation in angle. At that time we are using this cardinal joint or hook joint. Just we will see how the hooks joint. Here figure showing the universal hook joint. Okay, in that two yoke are used. There is one common spider, and how they are connected to each other you will observe in the assembly. Here where the hooks universal joint is shown, and this second figure shows the double cordon universal joint. In this diagram you will observe the driver and driven shafts are there, and these two joints are used. Okay, just we will see in detail how in this double cordon universal joint, in this double cordon universal joint you will observe that two closely spaced cross. Here are the double cordon joint and a yoke with spatial link yoke. Okay, here are the two points are considered, and this two joint works to reverse the non-uniform action and thus provide constant velocity. Okay, these two joints, this cordon joint and the slip yoke, provides to reverse the non-uniform action and provide a constant velocity. Means when the one shaft, as we say that it is a gearbox end and this is a differential end, and we require a constant velocity. What is the velocity at input shaft? That must be velocity at output shaft, and here the link velocity may increase or